Good afternoon, everyone. We'll start this session within few minutes. Until yesterday we were talking about exploratory data analysis, right? Okay, so today also we will look some more in depth. And today I'll share you guys another link that is course to be completed. We will start it now in a minute probably. So yes, coming to EDA, I will repeat again what I've covered yesterday, so that you'll have a clear understanding. Guys, please react if I am audible, and if you guys want to proceed. Yes, so let us continue. So, what is EDA? EDA stands for Exploratory Data Analysis, right? What is that? It is a process of using statistics and visuals. I hope you are all aware of what visuals mean. We also dealt with various kind of visual elements when we were talking about data processing, right? So I hope everyone are clear with that. So the process of using various data visuals and statistics to understand a data set, find relationship, understand the hidden patterns in the data set, and prepare it for further analysis. Okay, preparing the data set for further analysis, or any AI models. This is called EDA. Okay, let me repeat. So EDA is a process of using statistics and visuals to understand a data set, find patterns in the data set, find problems, or like find solutions to a problem, and then prepare it for further analysis or AI model. So this process is known as EDA. We just find the relationship between various rows and columns within a data set, and then find patterns, also give solutions to various problems. So this is all about EDA. I hope everyone's clear with what's basic definition of EDA. Give me a minute, I'll share you another PDF. I'll like share my screen so that you'll see. So yeah, I guys, I hope my screen is visible. So if you could see it, please react. Okay, fine. Let us continue with that. So even yesterday we have looked at several types of EDA and techniques. Those are multivariate, bivariate, and all of them we have seen it yesterday. But we will look at it again. Okay. So you guys can have a look at what is EDA. So EDA is an essential step in research analysis, as we have already talked. Yeah. The primary aim or goal of EDA is to examine the data for distribution and to find outliers and to detect anomalies. Okay. It also provides us various tools with the help of visualization. So under visualization, we also deal with graphical representation, right? All the histogram, bar chart, pie chart, all of these are graphical representations. So it also is used for visualizing and understanding the data, usually through through graphical representation. Next, it aims to assist uh, naturally recognizing the patterns within the data. As I have just mentioned, we have also learned that EDA is important step to understand the patterns and then find relationship within a data set. Also, feature selection techniques fall into EDA. So, what are the feature selections? Selecting only the features within a data set that are only required for us. So, for suppose if you are dealing with product catalog data, and then you also have what data, some, let us take, we have in the data set only, it consists of dead column, but it is not important for us. So what do? We do not select that. We only select the product catalog and how many products have been sold. So this is simply feature selection. Okay, so to make it more clear, let us consider we are dealing with sales data of what of the number of TVs or televisions that are sold, right? So in that column, just imagine that we also included mobile phone column. It is already pre-included, but I don't need that. So I only select features that are important and that help me predict the outcome of the model. So this is that simply. You guys can have a look at it or read it for a minute. There's nothing more. We have already seen all of this. So coming again, EDA is early step after data collection. So yesterday I have showed you a cycle of EDA, right? First, it included data collection and then data cleaning and then after EDA. So it is the step that occurs after data collection. It is telling that. And pre-processing. After pre-processing the data and collecting the data, cleaning the data, we we include exploratory data analysis. So here it is a early step after data collection and pre-processing where data is simply visualized, plotted, and changed, like manipulated without any assumptions. So it helps us assuring the quality of data. So as you can see here, most of EDA techniques are graphical in nature with few quantitative analysis. You can look at this for a minute. This is nothing but EDA. You can read this for a minute so that you'll be able to understand. These are all the things that we have discussed yesterday, and I have also repeated it today. I hope everyone's okay with this, right? Are you all following? Okay, fine. Let us move further. So we'll look now what are the different techniques and types of EDA. Okay, let us also look at the main objectives in EDA. So here the database is nothing but the data set. The main focus is to understand the structure of the data set. Yeah, okay. And then we try to understand the relationship and hidden patterns within the data set. Also, it is used to detect outliers. So it is generally of some types. They are graphical or non-graphical method, and then univariate, multivariate, or bivariate. Okay, these are all the main classifications of EDA. So then let us look it, into it with depth. Yeah, coming to techniques of EDA. So if we are dealing with categorical data, then suggested EDA technique is what? Statistics. And then if it is univariate, we are dealing with univariate kind of data, and if it is also continuous, categorical and continuous. So data is generally of these types. What is categorical data? Categorical data which is divided into groups or which exists as several units, and continuous data which is continuous. So coming to categorical data, the EDA technique that can be used is descriptive statistics. And then if we are dealing with univariate and continuous data, we have to use line plot and histograms. Okay, and then bivariate and continuous data. If it is bivariate and continuous data, then we use 2D scatter plots. So guys, these are nothing but these are visual elements that we use why to understand data. So as the name suggests, EDA is simply analyzing the data and understanding about the data. Okay, so if we take any kind of data and use hist- use histograms or line plot or scatter plot, you'll understand about the data in depth, like you'll just have a glance. So 2D scatter plot if it is bivariate and continuous if the data is, and then for two-dimensional array data, what do we use? We use heat maps. Guys, if you all can remember, we have also looked at this while we were talking about data visualization and visual elements in data processing. So when the data is multivariate or trivariate, what do we use? 3D scatter plot or 2D scatter plot. And then if the data is of multiple groups, we use box plot. So these are the different techniques that we use for different types of data. Okay, these are all not needed. We will just so coming to techniques, what are they? Graphical EDA and non-graphical EDA. So coming to here, and even within graphical and non-graphical, we will have univariate, bivariate, and all of this. First, coming to non-graphical EDA, it provides some insights into characteristics and distribution of variables. Okay, it gives us information about the variables, their distribution, how are they distributed throughout the data set, and then what are the characteristics of the variables. This is non-graphical EDA. So, as the name suggests, it is non-graphical. That is, these are the things that are not represented through graphs. So, coming to here again, univariate non-graphical EDA. So, what does this stand for? It includes examining a single variable. Univariate stands for single variable, right? So, examining a single variable at a time to understand how is it distributed, and then what is the central tendency, and what is spread. Okay, yesterday in the PPT I have shown what central tendency, spread, and distribution are. These are the terminologies that are used. And the main goal of this univariate analysis is what it is to describe the characteristics of individual data points. So, data points do exist in a plane, right? So, it tells the characteristics of these data points. Yeah, okay, let us continue. So, a simple univariate non-graphical ETL method is what? Building a table. Okay, building the table which contains the frequency. As I mentioned, table contains frequency, right? So here they have also given an example. These are the terms I was talking about: central tendency, spread, and distribution. So under univariate analysis for non-graphical, the measures of central tendency. So simply the central tendency measures are these: mean, mode, and median. Okay, the measures of spread. Coming to measures of spread are range, deviation, and variance. Also frequency tables. These are all the techniques that we use in non-graphical univariate type of EDA. Okay, mean, mode, median. You can see them here. I hope it's clear. Yeah, coming to central tendency parameters, arithmetic mean. Okay, what is mean? It is simply the sum of all data divided by total number of values. Coming to again, median. Median is the middle value, or the value that lies in the middle among all the values that are sorted. The middle value. So if there are all values, the middlemost value is called median. So yeah, coming to variance, we have also known that variance, range, and deviation come under measures of spread, whereas mean, mode, and median come under central tendency. So, what is variance? When calculated on entirely of data population, variance is obtained by dividing the sum of squares by n. So, this is a simple formula of variation. So interquartile range, don't worry if you do not understand it about that. It is again one of the things under measures of spread. These are all measures of spread. So IQR is interquartile range. What is it used for? It is used to calculate the boundaries of data. Okay, that are situated between first and third quartile only. Okay, These are all not too much important. So coming to skewness or kurtosis, what are they? Under non-graphical methods, this is one of the technique. This also comes under measures of spread. I hope everyone's okay with this. So coming to skewness and kurtosis, what is skewness? Is a measure of a distribution's asymmetry. And kurtosis, what is this? It gives us information about the smallest and largest values in the distribution. So both of these can be used as a means of communication. Okay, uh, like it is used to communicate about the information of the data. So we use all of these methods when graphical methods cannot be implemented. You guys might have known that we were all talking about non-graphical exploratory data analysis, right? So, what can be given as an example? Under non-graphical EDA, we can take example while we look at the distribution of customer ages or frequency of different product categories. So there are different categories of a product, right? The product might be related to beauty, it might be related to manufacturing, it might be related to healthcare. So it might be of any category. Also ages. So we will have several ages, right? We can take that as an example. Okay, coming to here summary. Coming to summary, what we have dealt with under non-graphical, we have three things. Those are central tendency, spread, and frequency table. Under central tendency means mean, median, and mode. We use them. And then spread. Spread includes range, variance, standard deviation, interquartile range, and last one is frequency tables. That is all about non-graphical EDA. Okay. And under graphical EDA, we deal with histograms, box plot, bar chart, pie chart, and all of this. So these all come under visual elements. We use graphical method there. So next coming to multivariate. Okay, yeah. Before going to that, we will look at univariate graphical EDA. As I've just mentioned, what all come under this histogram, uh, stem plot. It is one of the other type. Don't worry. Box plot and line plot. So all of these are EDA graphical methods. Univariate graphical EDA. Guys, I hope everyone's following. If not, please react or respond or whatever. Yeah, okay, fine. Let us look into that. So coming to univariate graphical EDA, histograms. What are they? Histograms are mostly used EDA techniques, which allows to gain trends into our data. It helps us to understand central tendency, outlier detection, and etc. What are they? They are bar plots. Each bar represents the frequency or the number of times they occur. Okay, next. These are all not too important. Histograms enable to confirm that an operation of data was successful. Mm, they are also used to find outliers. So, in an oximeter, the distribution of pulse can be showed as an example here, showing the presence of outliers expressed in fraction rather than percentage. Okay, this is an example of histogram. Okay, uh, this is what histogram looks, and these are bars. A single unit, it is known as bar. You can see here. This is that. Yeah, okay. Stem plot, you need not know, just have a look at it, what stem plot is. These are all not widely used. Okay, coming to stem plots, what are they? They are yet again a simple substitution for histograms. Like instead of that, these also can be used. What do they do? They show data values and then shape of the distribution. So this is the distribution. So you can have a look at the distribution of the what is this distribution of oximeter values, oximetry or pulse oximeter. So for an example, this pulse oximetry values. This is the distribution, and it is known as stem plot. You guys can have a look at it. So read it for a minute. You'll be able to understand just what a histogram is. You can have a glimpse. Let us continue. So coming to the next type, it is box plot. What are box plots? Box plot are another technique of representing information about central tendency. So what comes under central tendency? The mean, mode and median, symmetry, skew and outliers. But they are also used to hide some aspects of data. So box plot are an excellent EDA techniques because they rely on robust features like median, interquartile range, and etc. Okay, so these are important kind of EDA technique. The central rectangle is limited by Q1 and Q3 here, quartile 1 and quartile 3. So box plots are exploratory techniques. So there's nothing much important in this. That's why I'm not looking deep into them. Don't worry. So a box plot looks something like this. Just that's it. So the range here is Q1 to Q3, quartile 1 to quartile 3, median. So you might all have understood what an outlier is, right? So it is a data point that lies far away from remaining points. Example of a 2D line plot. This is a line plot. This is a box plot, and inside that, these are line plots. So coming to the last type, that is line plot. So coming to line plot, they they represent graphically the values of an array on y-axis at regular intervals of x-axis. So don't worry about that. This is simply a line plot. So yeah, let us further go into what multivariate non-graphical EDA. So we were looking at that. Now let us continue. So I have already mentioned what an outlier is, right? So how do you find outliers? Several statistical methods for outlier detection fall into EDA techniques. Okay, these are all so the various methods that are used to identify the outliers also fall into EDA techniques. What are they? Calculating the Z score, and then calculating the residuals, noise versus outliers, and etc. So coming to multivariate non-graphical EDA. So what is multivariate EDA? So examining the relationships among three or more variables simultaneously. So multivariate is three or more than three, right? So relationship among three or more variables. It is called multivariate analysis. So what is the goal in multivariate analysis? The goal is to uncover complex patterns and the hidden structures within the data set. And the main thing is it tries to identify the things that were not previously identified in univariate and bivariate analysis. So while examining the relationship between one variable or two variables, so what all have not been achieved, we try to look at them in this multivariate analysis. So as already we know, under multivariate we have again graphical and non-graphical. So coming to graphical, sorry, this is non-graphical. So dimensionality reduction techniques are used. What are they? Like cross tabulation. covariance, correlation. We also have PCA, that is principal component analysis, cluster analysis, and etc. But we will look at these only now. See, these are all covariance and correlation. Going to cross tabulation, what does it represent? It represents the basic bivariate non-graphical EDA. So it is just an extension for categorical and quantitative data with two variables. But for two variables, build a two-way table with columns. Guys, don't worry, we need not have in-depth knowledge about this. You just have a look at them, that's it. Next, coming to covariance and correlation measures. So what are they? These are just degree of relationship between two random variables. They indicate how they change together. So this is a formula that can be given. Positive covariance, what does it indicate? They are in the same direction. Like they move together in the same direction instead of some going this way, some going other way. All the variables move in the same direction and they move all together. While negative covariance, it means that variables go without any direction and some inversely go uh, in one direction and some in another. So you guys can see it there. Positive covariance, negative covariance. So what can be considered as an example? So we can give as an example how age, income, education. So for example, there's a customer, okay, that want to purchase something. So for example, if a customer tries to buy a television, so what are all the factors that include? It includes the customer's age, what is his income, and what is his education. So if he is of age below 18 and education he's still pursuing, and what might be his income? His income may be very few as he is still pursuing. And suppose a person's age is 35 and then his income is 50,000 and then he has completed his education. What is the chance of buying? It's more. So these are all the properties that are included. Until then, have a look at it. We will continue it within few minutes. So next we have graphical uh, multivariate EDA. So under these, there are also several techniques. What are they? Side by side blocks plots, scatter plots, and then PCA, as I have just mentioned. Next, curve fitting, all of them. Heat map, and this is surface plot. So coming to side by side box plots, what are they? They represent box plots that are side by side, which allows us to have easier comparison of several characteristics of the data. So an example is here. Have a look at it. So next we have scatter plots. What are scatter plots? Scatter plots are built using continuous, ordinal, or discrete quantitative variables. So each data points, what they do, they coordinate their coordinate corresponds to a variable. Okay, they can be classified into 5 dimensions: the data point size, shape, color, or etc. They can also be used to represent two high dimensional data, that is 2 or 3D data. So this is an example of scatter plot. Have looked at them for some time. So another thing is curve fitting. So it is one another way to understand the relationship between two variables or change in the values over time. Common method that is used is sum of squared errors between the data and the function. So this is an example of that. Guys, just understand or look at them. Don't worry if you do not understand everything in depth. Everything is not completely important. Just understand what are different types. So the next technique is heat maps and 3D surface plots. So these are again 2D array built grids. So according to the color, we have to identify the intensity, and color depends on values typically. This technique is only useful when we want to represent the change, okay, the change over time of an outcome variable. So color mapping can also be customized, like using rainbow or grayscale. So this is heat map and scatter plot. Guys, have a look at it. After a few minutes, I'll share you the link and give you time to do complete that. Until then, have a look at it. Today we will look at univariate and multivariate, and tomorrow we will look at other techniques. Even tomorrow we have to deal with EDA. So yes, I'll share you the link now. Guys, everyone enroll in this. Also give you some time. Everyone enroll in that. Guys, until now I have sent three, and I guess this is the fourth one. So I you have to complete all of them, but I'll share you remaining ones within coming days. Until now, you have to complete them. Guys, please react if you have enrolled or just have gone through the link. Yeah, so as I've mentioned, I have shared three until yesterday, and today I have shared one. That is total four. I have not shared anything regarding acquiring data. I have only shared Python basics and then data processing and then probability and statistics. And today I've shared EDA. That's it, guys. Yeah, after some time you can look into the course. Now we will look into another thing. And also look here regarding the types. So guys, read it for some time. Yeah, so coming to univariate non-graphical EDA, so this is the data that comes from making particular measurement uh, in a single like for a single characteristic, like it may be only age, gender, or speed at a task, and then response. So coming to categorical data, the characteristics of categorical variable are range of values that occur. So, for example, if we categorize subjects of college, some college that is Carnegie Mellon University, what are they? They are H&S department, MCS, SCS, and other. These are all various colleges and other. The population of all students enrolled in the 2007 semester. If we take an sample of 20 students and the subjects are these, they're not subjects basically. Yeah, so departments or subjects. What are they? HNSS, MCS, and SCS. So our EDA would look like this. See, so college, name of subjects, count, proportion, and percent. So apart from these univariate, multivariate, and bivariates, there are also several methods. What are they? Non-graphical EDA, then graphical EDA, ANOVA plotting, frequency table distributions, and all of them. We will look after them tomorrow in tomorrow's session. Till then, you can have a look at them. So this is multivariate EDA. Guys, once have a look at it. Just read. So don't worry if there's something that you do not understand. Just try to understand. So you have to complete all the four courses till tomorrow. Don't worry if you do not find enough time. You can also do them whenever you are free. Until tomorrow, try completing all the four courses. I think we have sufficient time for each course, right? We have given 2 days, and for one we have even got 3 days. So after a few minutes, I'll give you time to complete that. You'll also have tomorrow. Don't worry. So this is example of histogram. An example of histogram. Uh, so these are histograms for different bar width. So what is the bar width is very high here. That is very wide here. Whereas here it is comparatively less, and here it is comparatively uh, more than the middle one. So it depends on frequency. So here the frequency is more, whereas here it is less and small. So sorry, I forgot to share my screen. I was showing you guys. I will show you guys again. Don't worry. Don't worry about the issue. I have not even shared that. We will share that and we'll look after that. So, until tomorrow session, you have to complete till EDA. If you want another day for EDA, we can extend it. But try completing all the things till EDA. Tomorrow, I think I'll give you more time. So after a few minutes, you can utilize the time for the course. I hope my screen is visible now. So don't worry if there are any issues. There might be due to technical problems. Don't worry. So these are the histograms of different bar widths. Showing you guys this. These are examples of histograms with multiple samples. Univariate graphical EDA this is. This box plot. Guys, you can look at the course now. Go through the course. Try completing it. Yeah, that is it for today, guys. Thank you.